Hello viewers, today we are going to look at introductory chemistry, that is A-level chemistry. So we're going to look at some of the questions that came in one of the past papers. So let's focus on question 2. So question 2 says, a chemical name for limestone is calcium carbonate. Calculate the percentage by mass of carbon in calcium carbonate. So this is question 2. So A, the formula for calcium carbonate is like this. So the mass of calcium is 40 plus the mass of carbon is 12. Okay, then the mass of oxygen is 16. So by 3, which is down there. So this is going to give us 16 by 3, that is 48. So 40 plus 12 plus 48. This is going to give us 100. This is going to give us 100. So this is 100 grams per mole. Now, the question is saying we need to find the mass of carbon, that is in terms of percentage. So percentage of carbon is equal to, okay, the percent of the element in question, which is carbon, over, sorry, here it should have been mass of carbon over total mass by 100%. So percentage of carbon in calcium carbonate is actually, what is the mass of carbon? It's 12 over the total mass of the compound is 100 grams, okay, multiplied by the percentage itself, which is 100. So this is going to give us, when you type in the calculator everything, you're going to get 12%. So this is the percentage of carbon in calcium carbonate. So you've answered the first question and you're given 2 marks for doing that. And then the next question, which is B, was saying 5 grams of magnesium reacts with 2 grams of oxygen as indicated in the following equation. Find the limiting reagent. Find the limiting reagent. Okay, so what we need to do here is we need to establish the equation. We are told to say magnesium reacted with oxygen, and this actually produced magnesium oxide. So the first thing is to make sure that the equation is balanced. Let's see if it's balanced. So magnesium here is 1, magnesium here is 1, oxygen is 2, oxygen there is 1. So it's not balanced. So put a 2 here. So once you put a 2 there, meaning that magnesium is affected. So you need to put another 2 here. By doing that, it means the equation is balanced because magnesium here is 2, magnesium there is 2, oxygen is 2. The same 2 applies also to oxygen, so it's balanced. Okay, so after that, you need to find the number of moles of the reactants. So number of moles of the reactants is equal to, let's begin with magnesium is equal to mass over molar mass. So number of moles, what is the mass of magnesium? Let's go back to the question. We are told that 5 grams of magnesium. So the mass there, the physical mass, is 5 grams over, what is the molar mass of magnesium? Okay, magnesium is actually 24 grams per mole. So gram and gram will cancel, and therefore this is going to give us 5 divided by 24. This will give us 0.20833. This is the number of moles. You also need to find the number of moles of oxygen. So number of moles of oxygen is equal to mass over molar mass. So number of moles of oxygen is equal to, what is the mass here? You go back to the question. Okay, so the mass is given here as 2 grams of oxygen. So it's 2 grams of oxygen over the molar mass is actually going to be, okay, oxygen is like this. So I'm going to say 16 by 2, which is 32 grams per mole. So we're going to get that and put it here, 32 grams per mole. So you cancel this, and this is going to give you, so you divide there, divided by 32, and this is giving us 0.0625 moles of oxygen. Now that you found the number of moles of oxygen, we can now decide which one is a limiting reagent. So how do we do that? We are going to divide the number of moles in the equation by what we found. So for example, if you check in the equation here, magnesium, the number of moles of the equation here, it's 2, and what you found here after you've done your calculation is 0.20833. So what you're going to do is you're going to get that same number, this is magnesium, by the way, 0.20833 over, you divide by the number of moles of the equation, 2. You also do the same with to oxygen. So I'm going to say oxygen, that is in terms of number of moles, is going to be, what is the number of moles that you calculated? Here you got 0.0625. So you divide by the number of moles of the equation. So in this case it's 1. So once you divide by 1 here, it doesn't change anything. So you're going to get the same answer, 25, like this. Okay, this is still moles. This is also moles. So when you divide here, what are we getting? So what you're getting is magnesium is equal to 0.04165. So to determine which one is a limiting reagent, we need to look at the two numbers in terms of moles. Okay, the one which is smaller than the other is the limiting reagent. So 0.0625 and 0.04165. You discover to say magnesium, in terms of the number of moles here, is smaller than this one. So since the number of moles of magnesium is smaller than the number of moles of oxygen, we therefore conclude that therefore magnesium is the limiting reagent, meaning that it was in short supply, meaning oxygen was in excess. And this is how you find the limiting reagent given the equation. I hope this helps, and please share the video and also subscribe to our YouTube channel for more tutorials like this, so that you'll be able to understand some of these simple concepts that are being applied in chemistry. Thank you so much. Bless you.